Okay, similar idea with e to the x squared. Doesn't have a closed form antiderivative. It looks so simple, it should, right? Doesn't. But we can write down its Taylor series, Maclaurin series in particular, so a equals 0. The one you have memorized for e to the x, we can adjust it to make it e to the x squared, in other words. All right, let's write down the one, a little more scratch work here. Let's write down the one you have memorized, or you will have memorized for e to the x. Remember, it's the sum n equals 0 to infinity. It does not alternate. E to the sine and cosine are alternating series. E to the x does not alternate. So you don't need -1 to any power. So it turns out that it's just x to the n over n factorial after the summation notation. By the way, when you write that out longhand, what does it look like? What do you get when you plug in 0?
1.
When you plug in 1, what do you get? Just x. When you plug in 2, what do you get?
X squared over 2.
Right. I just put in the factorial for fun, but it's the same thing as 2. And then when you plug in 3, x keeps starting to develop a pattern here, right? A rhythm, 3 factorial plus x to the 4th over 4 factorial. Now you could write it without looking at the formula, right? Kind of looks like some weird combination of sine x and cosine x, doesn't it? Because it includes the even powers of x and the odd powers of x. And it is a combination of sine x and cosine x, except you have to use imaginary numbers to get it to match up. And in fact, it turns out e to the I usually use theta instead of x, is actually cosine theta plus I sine theta. But we don't have time for that. We have bigger fish to fry, so I just mention it in passing. All right, so anyway, memorize one form of e to the x and be able to come up with this guy one way or another. Okay, so then based on that guy, what is e to the x squared?
It's that times to the x, right?
Well, so what you do is instead of plugging in x, you just right here, you plug in x squared right there. And so you get x, and let me color code it. So you get x squared to the n. That's can't seem to write an x squared. Okay, x squared to the n. So that's where the x was, and then the n divided by n factorial stays the same. But then how does that simplify? Yeah. So it's the sum n equals 0 to infinity x to the 2n divided by n factorial. So that's what we're integrating, you guys. So long story short, the integral of e to the x squared dx is equal to the integral of its Maclaurin series, the sum n equals 0 to infinity x to the 2n over n factorial dx. And then you just integrate term by term. Put in a plus c right away. So c plus, what do you guys get for that when you integrate term by term? There you go.